Right, here we go. Is the next one up, which is grouped frequency tables. Now this is pretty much the same as a frequency table with that extra little bit that we have to do. And we mustn't get confused with frequency and group frequency tables. There is a little bit extra that we have to do. Right, okay, remember when we did the cups of tea or sausage rolls or something? So if we had sausage rolls, we either had 0, 1, 2, 3, 4, 5, that sort of thing. This was a frequency table. Now, there were no room for, say, if someone had 2.5. There's nowhere for it to go, is there? You either have 2 or you have 3. There's no middle ground. And so the this data is called discrete data. I don't think we really need to know that, but anyway, it's called discrete data where everything is discrete, separate. Yeah, there's no mixing; they never come together. Yeah. Now you can have continuous data. Oh, continuous. Oh, so many U's. Yeah, continuous data. Now that's what we do in grouped frequency tables. Now imagine we were measuring people's height as they walked through the door or something, and the first person was 1.8 meters, and the next person was 1.81 meters, and the next person was 1.805 meters. Now depending on how accurate you want to be, to do a table, a frequency table of this, would be absolutely bonkers, because if you were super accurate, you'd never have two people exactly the same height. So what we've got to do now, or they will do it for us, is we have to group all the data together into separate little groups, and we mustn't get hung up on Uh, we mustn't get hung up on what happens if there's something in between. So if we were doing heights, it's very simplistic here. We do everything HEI, GHT. The height of people in meters, yeah? 1.4 to 1.6, 1.7 to 1.9, and 2 to 2.2. So the groups, you grouped somebody, you measure them and say, oh, how big are you? Oh, I'm 1.6, well, you go in that one, and I'm 1.7, so you can go in that one. So we've only done it to the nearest tenth of a meter, so it's always going to be rounded up or rounded down so that it goes into a particular group. There is no such thing as there's a 1.63, because you'd round that down to 1.6 or a 1.67. You would round that up to be 1.7, so you're not going to get bits in the middle. You do when you do the GCSEs, but we're not doing that, are we? So we don't care. Yeah. Now, again, we've got frequency, and we'll do it. We'll just do it with these. I think we're doing it for the basketball team. Yeah. I don't know who's this big, but it doesn't matter. This might be the height of I don't know, a fence or something, or the height of a wall. Doesn't necessarily have to be the height of a person. So now we need to put some frequency in here. So we say we've got 5 people there, 7 people there, 4 people there, and 3 people there. Right. So remember, we've got to work out the haven't got to work out, but there might be the possibility of working out the range, the mode, median, and the mean. So you could be asked to work out any one of those 4 from a grouped frequency table. Now, over here, you will find that there are not one blank bit for the table, but 2. Right. So let's work out the range first. So the range is the difference between the smallest possible And just something I've forgotten, estimate. They always include this word in the question, estimate, because you cannot be sure of the individual height of these 5. They could all be 1.4 for what we know, or they could all be 1.6, or maybe 1.5. We just don't know. So that's why it's called an estimate. So the range is the smallest possible to the largest possible. So we've got positive answers for here. So we can include the 2.5. So 2.5 minus 1.4, which equals 1.1. So there's the range, 1.1 meters, between the smallest possible and the highest possible. Now the mode, again, is the most common reply, which is the highest number in the frequency column, and you won't get 2 of them, they'll always just make it 1. And this time the mode is 1.7 to 1.9 because the number 7 here is the biggest number. Now the median, again we do the old trick where we add them all up. 5 and 7 are 12, and 16, 17, 18, 19, that lovely awkward number, yeah? So it's n plus 1 divided by 2, which is going to be 20 divided by 2, which equals 10. Now that's the position of the median number. So let's go 5, that will be 12, so that's gone too far. 3, 7, 14, that's gone too far. So it's in here. It's this number 7. And we look to the left, and the median height is 1.7 to 1.9. All that pretty much is exactly the same as the frequency tables. Yeah, just a tweak difference. Now the one difference that is noticeable is when we're working out the mean. The mean. Now, we've got to use something here called the midpoint. Yeah, because as we said before, when we're estimating, we don't know whether they're 1.4 or 1.6. So what we do is we'll just pick the number in the middle and say, well, they're more or less. It's just a bit of a guess. They're all in the middle. Now to find the midpoint of these two numbers, you add them together and divide by 2. But these are quite obvious to see what the midpoint is. This is 1.5. This is 1.8. This is 2.1. And this is 2.4. I'm going to reach for my calculator in a minute. Now we've got our last column, which is our total column. So we multiply the midpoint by the frequency. Oh, it's a bit long-winded this, yeah? So 5 times 1.5 is nothing because I pressed the wrong button. 5 times 1.5 is 7.5. 7 times 1.8 is 12.6. 4 times 2.1 is 8.4. Sure, I could do some of these in my head, but I'm not. 3 times 2.4 is 7.2. Right, now we need to add all this up because this will give us the total estimated height of everything. Yeah, so 7.2 plus 8.4 plus 12.6 plus 7.5. All right, 35.7. 35.7. So this is the number of people, say, and this is the total height. So to find the mean, estimate of the mean, so I'm going to write estimate of the mean is 35.7 over 19, or divided by 19, which is equal to 1.8. I'll round that 1.8 to 2 decimal places. I've got thousands of numbers in the calculator. Whoops, where have we gone? Come back. 2 decimal places. Okay, that's it. So be prepared to be asked to work out any of these four from a grouped frequency table. Um, the chances are you won't be asked to work out all four of them, but you've got to know how to do all four. So let's have a look at a couple of things in the book. So what we've got here, see how we've got two blank columns over there? Stanley records the age of everyone in the snooker club. Here's the ages. Find an estimate for the mean. You can use the empty column. So all we've got to do is work out the mean. We haven't got to bother with the range and the median and the mode. So the first column is going to be the midpoint. And the second column is going to be the total. So the midpoint of 14 and 18 is 16. The midpoint of that is 21. The middle of that is 26. The middle of that is 31. And the middle of that is 36. Okay, so now we need to multiply these numbers together. Okay, calculator. 19 times 6, 114. Oh, it's easy to make a mistake here. 3 times 21. So many numbers. 63. 26 times 2 is 52. That's 31. And 5 times 36 was 180, yeah. Okay. See, now we've even got another row down here. So we need to count up all of these. No, we don't. No, we need to count up the frequency. Confusing. Yeah, so 9, 10, 11, 12, 13, 14, 15, 20. Now we need to count up the total age for all of the people in the snooker club. So we've got 180 plus 31 plus 52 plus 63 plus 114 equals 440. And these are the people, this is the age. We do 440 divided by 20. So it's going to be 22, doesn't it? Divided by 20 equals 22. 22 years old. Yeah? Give your answer to the nearest whole number. Well, it worked out perfectly the way I did it anyway. It might not be right, but I think it is. 22 years old. And we're in there, aren't we? Because there's lots of young people. That's why it sort of pushed the average younger. The table below shows information about the number of calendars sold on a calendar stall each month. So here's the number of calendars each month last year. 1, 2, 3, 4, 5. There was only 6 of them. So it wasn't the whole year, was it? So anyway, don't matter. Work out an estimate for the average number of calendars sold each month. So work out an estimate. So they haven't actually said in this one, 114, let's see, what they want us to work out there. But I would imagine 30.75. I would imagine we're going to do, let's do the mean. Let's find the mean whilst we're in the mean mode. We're in the mean mode. We could do the median as well. Yeah, let's do the mean first. So we need a midpoint and we need a total. So let's count this up. 6, 7, 8, 9, 10, 11, 12. So 12 it all together. And the midpoint of 0 and 14 is 7. Now, I'm going to do this 15. Here it is. I'm going to do 15 plus 29 divided by 2. So 15 plus 29 divided by 2 equals 22. So that's how I'm finding out. So I need 74 divided by 2, 27, and 45 plus 59 divided by 2 is 52, and 60 plus 74 divided by 2, 67, and 75 plus 89 divided by 2 equals 82. I've just noticed there's a lot of zeros in here. So, okay, so there's our midpoints. So now we need to multiply that. 6 7s are 42. 122 is 22. Got that easy. 0 times 37 is nothing. 252s are 104. 3 times 67, I can't do that in my head. 0 times 82 is nothing. So 3 times 67 is 201. Right, add them up. 201 plus 104 plus 22 plus 42 equals 369. So the mean equals 369 divided by 12. 30.75. 30.75. Should we do the median as well whilst we're here, yeah? So do the median. So, the median. They didn't actually say which one they wanted us to do. They just said work out an estimate for the average. So the median, n plus 1 divided by 2. So it's 12. So that's 13 divided by 2, which equals 6.5. So we can count 6.5 up. So 3, 4, 5, 6 point. Hang on. 6.5. That's awkward. That doesn't make n plus 1 divided by 2. 12. 12 plus 1 is 13 divided by 2 is 6.5. So 6.5. 6.5 is in air. So 3, 4, 5, 6.5 is in there. So the median doesn't work, does it? 3, 5, 6.5 is there. 6.5 is there. Doesn't come out to be there. The middle. What have we done wrong? 12, 6, 7, 8, 9, 10, 11, 12. There are 12. That is maybe because of these zeros are making it more difficult. So 12 plus 1 is 13. 13 divided by 2 is 6.5. So 6.5 from the end. 3, 4, 5, 6. 6.5 is there. 6.5. It's on that line, isn't it? It's on that line. So it's just between. It just doesn't work, does it? This doesn't work that way. The median, it doesn't work. I wonder why. Because it's grouped. I'm going to have to give up on that one and say the median doesn't work. What do they think? What do these stupid people think on page 114? 30.75. So they have expected us to work out the mean. Yeah. The median didn't seem to work in this example. It would have been nice if they'd have said work out the mean, and they will do in an exam. This is just a textbook. Oh, right, so we've done that bit. Yeah, so a worksheet on this one, and I'll see you in the next.